Welcome back. We've had lots happening. So Charles just wanted to come along, share his thoughts about the halving and the other exciting event so far this year, the DAO. Who owns DAO tokens? A bit sheepish, a little bit sheepish. Come on, don't be shy. They'll be worth something one day on the Antiques Roadshow. So anyway, without further ado, I will hand over to Charles Hoskinson.
Hi, everyone. Mic check. There we go. Okay, so first, thank you so much, Gordon and Louis and Tomer, for the hospitality and inviting me here. It's always a pleasure to come to Coinscrum. This was completely unplanned. I didn't know I was speaking today, so I actually didn't prepare anything, but I guess you get to receive my extemporaneous ruminations about my thoughts in the space. Anyway, I'm also a bit fogged because I was just at BIP 001, and we were in Odessa, Ukraine, and it was a 3-day event. We slept for about 4 hours over all 3 days. The highlight of the trip was about 6 o'clock in the morning coming home on a horse to my hotel. So that was fun. Tie up the horse right at the front of the hotel, go in. Oh, it happened. It happened. Beware those Ukrainian horse taxis. Okay, so anyway, after that it was Warsaw, Poland, and then here, and we've been in meetings all day. So I'll try to get through it, and we'll try to have a lot of fun. So my name is Charles Hoskinson. For those of you who don't know me, I've done 3 cryptocurrency ventures. The first was Invictus Innovations, and we started BitShares, that nice project from 2013 that tried to build a value-stable currency. The second project I did with Vitalik Buterin, Gavin Wood, and Jeff and others, and that's Ethereum. Usually that's the project people know me from. And now I'm the CEO of Input Output. We're a company based in Hong Kong, but we operate in about 6 countries. We have 27 employees. We're a service and a research company. On the service side, we build cryptocurrencies, and that's everything from the governance model to setting up a crowd fund to going out and actually implementing it. Full Haskell shop, so everything we do is functional. On the research side, we focus on first principles. So we can do everything from design a new consensus algorithm to do secure multi-party computation research to zero-knowledge proofs. We kind of think about all of it. We have a lot of cryptographers who work with us, especially in Ukraine and Russia, and a few academic partnerships that we've set up. So that's a little bit about my background and my company. Today, I'd like to talk a bit about the history of cryptocurrencies and kind of where we're going, and then end with the DAO as kind of an elucidating discussion. So first, a little bit about the history. Where did cryptocurrencies come from? So the first generation of cryptocurrencies was all about transactions and immutable ledgers, these types of things, digital scarcity. So the question was, could you build a decentralized currency? And guess what we did? Great. And what did that mean? It meant that now Alice can send money to Bob, kind of like you send an email. And that's really powerful. And so all of a sudden we started having all these discussions about what is a good decentralized ledger, and they're still going on. So that's kind of the first generation. And then all of a sudden people said, well, wait a minute, these transactions between Alice and Bob, they're really dumb. They just move value. Wouldn't it be so cool if we could attach instructions to them? You know, terms and conditions, say if Alice mows my lawn, then I'm going to ship the money to her, but then and only then? Okay, well, that's a smart contract. And that's kind of the second generation. These are the things that Sergio Lerner and others started with, and eventually Vitalik Buterin kind of got right with Ethereum. So we're right now in cryptocurrency world kind of in the second generation of blockchains. But actually there's a third generation that's rapidly emerging and happening. And these are the things where all of a sudden you start talking a little bit more seriously about the meta, i.e. the governance of the system. Okay, what the heck does that mean? Well, let's think about some very simple debates we've had. It's simple to understand but hard to resolve. For example, the block size debate with Bitcoin. Okay, so some people say it should be this big, some people say it should be this big, some people say do nothing. This is a governance discussion. There's technical reasons, but there's no formal mechanism in the protocol itself to actually decide how to amend or change the protocol, right? It's all happening on Reddit and Bitcoin Talk and all of these other places. So it's basically a rule of whoever has the biggest microphone and the most influence, not necessarily an explicit, well-understood process. Similarly, let's look at the DAO situation that's going on right now. So you have a situation where people have said, okay, should we bail out the DAO or not? Should we fork or not? Should we rob the thief or let the thief rob the people? Okay, it's a question. It's a philosophical question, and it has deep implications about the platform. So how should we go about asking the people of the Ethereum community whether this is a good idea or a bad idea? Okay, so the third generation of blockchains is all about, can we make this process explicit? Instead of having it be implicit and be meta to the protocol and be whoever has the loudest microphone or whoever has control of the code, can we create a system within the cryptocurrency, kind of like the Constitution of the United States has a system to amend the Constitution, a way of amending the ledger. Now, that's not a new idea. In fact, in 2014, L.M. Goodman, now known as Arthur Brightman, wrote a paper called Tezos. And in that paper, he proposed separating your cryptocurrency into 3 sub-protocols: a network layer, a consensus layer, and a transaction layer. And it turns out that if you're very clever about that design, you can actually develop a system where people can make proposals to change any one of those protocols in a deterministic, machine-understandable way. So then, all we're debating now is, what is the process? How long does it take? Who are the stakeholders? Who gets to vote? How do we actually interpret the philosophy of a system and whether it's compatible with the philosophy or not? And so Arthur is kind of a nice academic, and so he actually looked to the 1980s to a system Peter Suber developed, a game called Numic. And basically this game is where it's a very simple game, and in the game is a set of rules to change the rules, including the rules to change the rules. So it's kind of meta there. And it turns out you can develop these elaborate, extremely complicated games as a result of just gradual evolution from voting and other processes that end up being very elegant. And there's actually a lot of documentation and papers and literature. So Tezos actually is going to be implemented, and in September going to be released, according to Brightman in his recent Epicenter Bitcoin interview. It's written in OCaml, and it's going to have built inside of it a system to actually change the blockchain. That's kind of the 3rd generation, the governance system. Now, closely related to this is this idea of a DAO. So what the heck does that have to do? Why do we care about DAOs? What's interesting about DAOs? Well, the first guy to really start writing about this in the cryptocurrency space was Stan Larimer. At least that's the one I know of. And when I was running Invictus Innovations, he was our chief operating officer. And he was sitting on a sofa, and he had all of his books from Arthur C. Clarke and other things, and he wrote DAX and the Laws of Robotics. And he wrote this really lovely Bitcoin Magazine article, basically describing what a decentralized autonomous company is. And it came up with these pithy comments. It's a beautiful article. I highly recommend reading it. Right around the same time, Vitalik started writing these papers about a DAO. Now, to simplify this, all it's really about is you have some structure that requires governance. So it has something where decisions have to be made. And the question is, how do you make those decisions in a way that is not controlled by a single entity? It's decentralized in some way, and we're removing human beings from that factor as much as we can. It's basically the goal, the philosophical goal we have. And when you start thinking about that, you start realizing that this is a really good notion for certain things in society and life. The development of the Linux protocol, the development of BitTorrent, the development of any cryptocurrency or open source project. It'd be really nice to build some sort of decentralized, inclusive process that also takes economics and incentives in play and is deliberate and deterministic. That would be really nice to have. Okay, also allocation of capital. Wouldn't it be cool if cryptocurrencies had their own treasuries? Like Bitcoin had its own development fund, and it would be able to just open up its wallet, and there was some balloting process, and Blockstream could say, I want to be a core developer for Bitcoin, and Bitcoin actually just sends Bitcoins to Blockstream to write new BIPs or implement BIPs or things like that. It's a pretty cool idea. Unfortunately, these ideas are encapsulated in thousands of booby traps and cobras and other terrible things. Why? Because they involve people. And algorithms are really dumb, and people are really smart. And if a human designs an algorithm, there's going to be a human who's really good at designing a way out of that algorithm to steal funds. And that's exactly what happened with the most recent DAO, which was just basically a really simple pool of capital. So some guys from some company that shall remain nameless made a decision to maximize decentralization without any safeguards and accepting any personal liability. So they wrote a bunch of code, and they thought it worked, and they wrote it in a language that really doesn't give you any formal guarantees, solidity, and then they went ahead and released it, uncapped, and let $150 million of value pool, assuming that somehow random people over the internet would be better at investing that money than professionals. Okay. And it's the wisdom of the crowd's argument. Everybody has a right to do that and participate. The problem is that code didn't behave the way that they intended. Now, the philosophical question, and this is the fundamental of a DAO, is when you turn the driver's keys over from the Ferrari to a machine, you have to sometimes accept that the Ferrari is going to kill people. And you have to accept those consequences. And when you start intervening, it kind of diminishes the entire purpose of these types of systems in general. The other thing is it creates a moral hazard of when and how do you intervene. In the case of the DAO, I was against the intervention because I remember Gatecoin. They got hacked and millions of dollars got stolen. Will there be a fork to return their money? I remember all the Ether buyers who invested millions of dollars and lost their wallets. Should we intervene to go ahead and reverse those people? So why do they get screwed and the people who put money in the DAO not be? Is it because the foundation has a very close relationship to the DAO? Okay, maybe, maybe not. And this is one of the fundamental problems, and this is why actually I believe the third generation of blockchains is actually making this process more explicit. It's all about aggregation of information. It's all about identifying the stakeholders, identifying conflicts of interest, and creating a systematic process for us to actually make decisions about what to implement, what BIP to choose, what BIP not to choose. And this has to be deliberate and slow. The good news is there seems to be empirical evidence from thousands of years of human history of government systems that have been pretty immune to coercion, or at the very least, protocols that have been pretty immune to coercion. For example, the U.S. Constitution. Every year, we have a lot of people who say, maybe we should get rid of this amendment, or add this amendment, or do something wonky here. And every now and then they actually get it done, like prohibiting alcohol. But more often than not, it's such an expensive, time-consuming, brutally difficult process that the political consensus has been to just simply ignore it, as opposed to amend it. And so that's actually something that's nice because that can be a program, and you can't ignore programs. So the point of this presentation, and I'll end it here, is that I believe we're entering the third generation of cryptocurrencies. The DAO and other things force us to explicitly acknowledge this. And that's the generation of governance. And so I'd encourage you to read Feudocracy from Robin Hanson and learn a little bit about that. I encourage you to read about Nomic and Peter Suber's work. And when Tezos is released, I'd encourage you to spend some time with it. And at IOHK, we're actually going to be launching a DAO lab internally. And at some point, we'll probably over the summer have open participation and bring a bunch of people in and try to get some of the boundary conditions of what this technology can and cannot do and identify some of the hazards and pitfalls for the community as a whole to kind of research and consider. All right, having said that, I'll open up to questions. And I love questions.
Hi there, thanks. Do you not think that there's an argument to keep rules around governance inexplicit in order to hope that that could improve censorship resistance, for example?
No, and the reason being is you can always change the rules back to an implicit basis. So one of your acts can be to remove the mechanisms to explicitly change the rules. So if you discover there's moral hazards, you can reverse them and remove them. I think it's always better to attempt to at least create a process to follow that people can agree is a good process or a reasonable process, then leave it into an implicit kind of meta process. Because what ends up happening is you end up having usually rational ignorance. You have most people, they don't feel like they have a say or an ability to do anything, so they just don't care and they zone out. And then only a small group of siloed power wells form, and those people end up controlling the protocol. In the case of open source projects, it's usually the core developers and the people who have invested the most money in the particular project. In the case of Bitcoin, it would be like exchanges, wallets, and the core developers, as well as the miners. If they agree, well, tough cookies. Is that a fair representation when, let's say, 99% of the other actors using and gaining utility from the system are not represented? That's a fair question to ask. But the point is, we haven't asked it. What we've done is we've just implicitly assumed it. And what's nice in an explicit system is you at least know the rules of the game. So when you buy a token in that system, you say to yourself, oh, okay, I am buying into the philosophy, and I know what the philosophy is. I know what the Constitution is. It's kind of like you're on a map and trying to decide what country to live in, and you get like an executive summary of the philosophy and laws and rules of the country, and you're like, maybe not North Korea. You know, Switzerland looks pretty good. I'm not so sure about Chile. Probably a good country. But, you know, that's the point, is that you at least get some knowledge of what the governance system is when you make these immigration choices. Similarly, when you're making choices with your money, potentially choices with your legal system, because that's what smart contracts enable, it's probably important to understand what the governance system is explicitly, instead of just leaving it up to chance or to people that you have no ability to vet. Next question.
Hi, yeah, you just mentioned legal systems there. Do you need the backup of a legal system, i.e. a traditional legal system, to actually enforce some of the things that you're talking about in a DAO. So, you know, did the guy actually steal the money because he was allowed to take it through the code? So do you need some recompense through a traditional legal system?
Well, whether you need it or not, it's there. And the other thing is that there are physical things like cars and gold and other such things. You can't engineer a protocol to like reach its way out of the internet and grab a bar of gold and take it along with it. So when you have a marriage between the physical world and the digital world, you do require some form of a legal system. The question is which one and who gets to decide. So, yeah, you know, the Europeans, they're pretty clever. They came up with a system called lex mercatoria back in the 12th century, and this was the law of the merchants. So instead of, you know, being a merchant going to France and all these other places and just always being under their local system, they actually created their own legal system, specifically just for merchants, and the merchants' guilds would decide it. So there's a modern-day equivalent to that, and that's maritime law. Think of being a shipping company. You know, you go to 80 countries, 100 countries. Do you really want to have to worry about the legal systems of every single country you're in when you create contracts, or just by default bind to the United States? It makes no sense. And so they actually have created a transnational legal standard. So similarly, because law ultimately is made by analogy, at least in the Western world, it's probably a good idea to actually use those as inspirations to build a transnational legal framework that also starts talking about smart property rights, starts talking about digital signature rights, start talking about custody. Look, think of the DAO in its logical extreme. Pool of money, and that pool of money can be used to buy things. So what if the DAO buys a house? Who owns that? You kind of need a government to recognize in some form or capacity that this pool has some form of custody over that. Think about being a counterparty to the DAO. Yeah, there we go, the DAO operating company, run by Slockett. So think about being a counterparty to the DAO. So the financial system is always built up of where did you get the money from? So if I go to my bank and I have a deposit and I say, hey, look at all this money I have. And they say, oh, great, where did you get it from? It's like, I got it from this anonymous pool of dark money on the internet called the DAO that nobody controls. They don't really get that. So you do need some form of regulatory framework that probably is going to work well. And it also has to be transnational because this money is transnational. It moves from China to America to South America in a drop of the hat, just like email. So there is some inspiration on how to regulate the internet versus how to regulate this system. And I think we can learn some things from the failures there and the successes there with respect to building a transnational framework. Second, I think we can learn from history and look at maritime law as well as lex mercatoria. Next question.
Hi. Bitcoin had some really specific use cases, well, one maybe, and then Ethereum came along with smart contracts and things like that. I mean, who's going to be interested in pure governance, or is it that it's a blockchain that does exactly what the other blockchains did, but with a good governance system, and that's why you would prefer to use that one rather than anything else?
Yeah, so remember, cryptocurrencies are upgradable. So it's like going from Windows 95 to 98 to 2000. You're still in the Windows ecosystem, or you can move to Linux. So similarly, Bitcoin can be upgraded to a 2.0 system, and this is being done actively with Rootstock. The minute Rootstock comes in at the end of the year, Bitcoin has the same smart contracting abilities as Ethereum does. So it is now a second-generation cryptocurrency. Similarly, whatever proof of concepts are released for Tezos and other things for governance, those will be their own little systems, and we'll be playing and experimenting with them. But at some point, it will be probably backported into Ethereum and backported into Bitcoin. So the argument of whether is it a good investment to be in this next generation thing or not, from a speculator's position, it's you know, your best judgment. But from a technology position, it's more of what did we learn and what can we steal and bring back into the system. So I think what's going to happen is it's going to ubiquitously occur, just like Ethereum is forcing an evolution of all systems to evolve. Tezos, for example, has a smart contracting system. And so it is second generation in that respect, and now it has a governance system. And actually a better smart contracting system than Ethereum does.
So you're talking about regulations, governance systems, the need to have a custodian for any sort of thing that ties into the real world, and reversibility. All of these things basically imply or tie towards centralization versus decentralization, and a few or a central actor rather than a decentralized network. What's the so I guess what I'm asking is, what's the need for what's the need for decentralization in smart contracts, and does this all not revert back to the existing financial system? And why do you need to do this with blockchain and proof of work and decentralization?
The what is the point and why are we here question. I'll try not to be Dan. Yeah, I know. I'll try not to be Dan Quayle. Okay, so with respect to that, Vice President of the United States, 1988 to 1992. Okay, so anyway, with respect to smart contracts in general, do we need them to run in a completely decentralized capacity versus run in a centralized capacity versus run in a federated capacity? And the answer is it depends. Do you need a coupe? Do you need a sedan? Do you need a truck? Do you need a tank? What's the distinguishing factor between these? It's the context, the applications, the things you're attempting to do. So I'll give you a real good example of where I would like a maximally decentralized global system. Gambling. Why? Because I really don't trust some rinky-dink jurisdiction in the middle of damn nowhere to say that these random numbers are randomly generated. I really don't trust them to handle player matching in a fair way. I just don't. And so, yeah, I could trust some, online gambling site that they're not going to show the person I'm playing against my cards. But in all honesty, I'd like some sort of cryptographic guarantee in that respect, that that's the case. Now, yes, actually, this could be served efficiently in a federated capacity. An argument can be made for that. But the minute you do that, if your goal is to have free, fair games that are immune to any form of government coercion, the minute you have federation, I can put a legal topology on that and say that those federated nodes who are responsible for validating these contracts are casinos and require regulation. So in this particular case, we have to maximize decentralization if your goal is, I don't trust the government and I really don't want them to have any say at all in my experience, but I want to actually have provably fair gaming. Now, let's think about a different scenario. Let's think about gold. Ownership of gold, and I have a custodian. Why in God's name do you need a smart contract that is decentralized? If somebody has your gold, it doesn't give a fuck if the contract is reconciled over a network of 10,000 people versus the custodian. If the custodian decides to hold on to your gold, you're done. So you might as well embrace centralization in that case, because at the very least you get efficiency. And you can at least argue about the reputation. Now you can talk about certain things, like maybe we can handle the auditing of that in a federated way, or other aspects. And that's where you get into the actual spirit and complexity of the deal itself. Because nothing in life is simple. Every commercial transaction has kind of what we see, the tip of the iceberg. And then there's all these assumptions that we make. That's why you have force majeure clauses in contracts, because that's all the stuff you don't see. There's tons of things you don't see in your contracts. And so when you think about these systems, you say, okay, well, maybe I can have a centralized contract here, but for all of these things that could go wrong, maybe I should actually start decentralizing these types of things. The final point is, let's think about identity. This is a big problem in the developing world. Let's look at Syria, millions of refugees or other places. So in these cases, we have people who should be trusting centralized institutions to tell us if they're good people or bad people, or even who they are. Birth certificates, passports, and these other things. But the state itself has failed. And so if you have property rights that are connected to a centralized identity store, and the centralized identity store dies, you actually lose all the property rights as well. So when we put Afghanistan or Syria back together at some point, because we always do, and people come home, they're going to come home, and who owns the land? Who owns the property? Who owns what? And every time in human history this has happened. After the Holocaust, after the Armenian genocide, after all these events. People come home, and somebody's living on their land. Somebody owns their house. Somebody has their paintings. Somebody has their property. Their credentials have been lost. So in these types of systems, it seems reasonable to say maybe we should build a decentralized identity system. Maybe we should build all the logic for reputation and make that as decentralized as possible, so that one government can't co-opt it, or one government going down doesn't destroy the system. Or maybe it makes more sense to still have that be a federated system, but at least with some auditing. That's my best non-answer to your question. Thank you.
Can you talk a little bit about consensus mechanisms? Do you see anything replacing legitimately proof of work anytime soon? Speaking of Casper network, things like that, what do you see on the forefront over the next 12, 24 months? Is proof of work where we're stuck? Can we evolve from that? What are your thoughts?
Okay, so consensus mechanisms are connected to the distributed systems they secure. So you think about properties from a theoretical sense. You think about liveness, and you think about consistency, you think about correctness. These are all properties. And ultimately it comes down to what is your network topology, and what are your assumptions about privacy, and is everybody a first-class citizen, or do we actually have different levels of nodes? For example, what if you have a network where there's some set of people that you trust, absolutely trust? You say, I like these guys. Maybe I don't trust an individual, but I trust the group. So in that case, you don't want to use proof of work at all. It makes no sense. You should use Paxos. That's been hardened for Byzantine fault tolerance. And all of a sudden you get orders of magnitude more efficiency and throughput with your algorithm. Okay, and this is what JP Morgan Chase is doing with Juno. They have BFT Raft, which is a variant of Paxos. Okay, so that's your federated viewpoint of consensus algorithms. It's going to happen, and it's going to work for interbank changes and internal systems. Okay. Now, what does proof of work give us? Well, it maximizes decentralization. It gives us DDoS resistance. It gives us all these good properties. It allows us to find the longest chain because you have algorithmic weight. Is that valuable? Does that provide utility to a certain extent? Is it worth $3 per transaction, which is what we're actually paying right now? That's debatable. Okay, so the question there is, can we come up with something more useful and better to justify how much money we're spending, or perhaps something that is more economically efficient in terms of understanding the characteristics of the network? Like in ordinary networks, you don't just say, let me spend the same amount of money on my hosting, whether I have a user on my website or I don't. Think about that model. So I came up to you and I was like from Amazon. I said, oh man, Amazon Web Service is so awesome, man. $10,000 a month, flat rate fee. You say, but yeah, I only have 5 users. No, man, $10,000 flat rate. No hosting in the world works that way. But that's what we're doing for Bitcoin. Think about it. We pay the same amount for the block reward, whether there's lots of transactions in the network or no transactions, whether there's a crisis event in the network or no crisis event. So if one is to enhance proof of work, there's plenty of proposals for this. Non-outsourceable puzzles to remove mining pools, but still deal with some of the variance issues. There's been proposals to get rid of cloud hashing. There's been proposals like Permacoin to get rid of, to make proof of work more useful. In fact, we're doing our own at our own company called Roller Chains. So there's all these ideas that have come into play, and then some ideas saying maybe we can actually tie the block reward to what's going on in the network. Pay more when the network's under strain, pay less when the network's lower capacity. Okay, so if there's going to be improvements to proof of work along those lines, but preserving the theoretical property of finding the longest chain, that's what's going to happen. Now, proof of stake is really interesting, because what proof of stake does is it's a philosophically different model. It says, okay, I don't really care too much about mining. Instead, what I'm going to do is designate some group of people as stakeholders and say these people will now have control over the network. And if you could prove that this was formally secure, you would gain all the security benefits of proof of work, except for one. You can't determine the longest chain. You still need some sort of checkpointing system. Now, there's a lot of meta questions that go into that. Is this a plutocracy where the people who have the money are in just total control, or are we going to use a different algorithm to decide who the stakeholders are? For example, NEM has proof of importance. And actually with BitShares, we had a hybrid system where we had stakeholders, but then they voted for delegates. And that's called DPoS, delegated proof of stake. And those delegates then used something like Paxos. So we try to have the best of both worlds. That's called a dynamic quorum Paxos system. So I think the answer to your question is it depends on your network topology and what you intend on using your network for. If you're a MasterCard, Visa, or JP Morgan Chase, or any of these other guys, you have people you trust. And you have regulation that you have to think about, and you have certain things where maybe you need to actually perform 51% attacks to upgrade the network to comply with regulation, for example. And in that case, you want to keep your quorum small, predictable, trusted, known, and use a traditional consensus algorithm. If your goal is maximum decentralization and we want to have a totally anonymous currency and fuck the government, then you need to use a completely different consensus protocol, and it just comes down to what are the resources you're willing to commit and what is the social contract you have with your particular users. And I think that's much more to do with kind of a philosophical viewpoint than it is an InfoSec standpoint or a distributed systems standpoint.
Did you get, one quick question, did you get the $3 per transaction from the energy costs that we're using on proof of work? Where did you get that number from?
That's just the minting cost. You take the amount of coins that are produced, and then you go ahead and times it by the market price, and then you divide it by the transaction per second rate that the blocks have. And that's not from me. That came from on-blockchain scaling from IC3.
That's inaccurate, though. So you're conflating I agree with the math, but the problem is you're trying to conflate two things, which apples and cars or something.
Okay, so it's not Charles Hoskinson who's doing that. That's Cornell University and University of Maryland.
Sure.
So just important to point that out.
I'm happy to criticize anyone who's getting something wrong.
Okay.
You're conflating inflation, the inflationary subsidy, with transaction fees.
What?
So
hang on. So you're minting new money, and so new money enters the system.
Hold on.
And it's sold. It decreases the value. So you have to have demand increase,
Think about
right?
it like this. Think about it like this. If you counted the cost of doing a Visa transaction, a cash transaction, a SWIFT transaction, if you counted the cost associated with the amount of inflation that happened in the time that transaction took, then you could actually get an accurate comparison between the type of traditional financial institution networks and what's going on in Bitcoin. But no one in the world, in any financial sense, counts payment costs that way. No one thinks, oh well, the U.S. dollar inflated 2% per year. So we'll divide that by the amount of time. The 3 days it took my SWIFT transaction. 3 days divided by 365 will take 2% times $70 trillion.
So what payment system has its own built-in currency?
That way.
What payment system has its own built-in currency?
Every currency in the world has a built-in payment system.
Okay, so hang on a second.
The Fed has FedWire and ACH.
Okay. Listen,
Bank of England has its own payment system.
We have
India, and every single currency in the world.
So, first question I have for you is: if you hold Bitcoin and all things are being equal, and new Bitcoins are being created, you're saying that doesn't have an effect on the market, or are you saying that doesn't matter because the other systems commit the same sin?
I'm saying there is a term for that in economics, and it's called inflation.
Yeah, and inflation deteriorates the value of your money.
Yes,
and we're paying inflation to secure the network.
But yes, exactly. That's my point. The problem that you're saying is that you are counting that as a cost of making a payment, which it is not. You said, and correct me if I'm wrong.
Will the system function without mining of money? Will it function without money? How do you guarantee liveness?
I certainly hope not. I'm here because I'm here.
No, hang on. If I don't offer mining rewards, what would the hash rate be for Bitcoin? The only reason Bitcoin advances from one block to the next block is we pay people. So that's the cost of validating transactions.
And it's called
inflation. And we create new money to pay them, which deteriorates the value of the old money, and that's a cost the network carries paid for by new money entering the system. I'm sorry, I disagree.
But, okay, anyone in an economics context would call that inflation. New money entering the system. Is that not inflation? Does anyone here think that new money entering a financial system? It's done in a different way, sure. It's done to secure a network, sure. But
I'm paying the staff from the Bank of England and the politicians and whatever that make the centralized system work so that you can have trust in the currency, so that everybody can trust that currency. Whereas in Bitcoin or cryptocurrencies, you're paying that proof of work is the cost of the transaction, otherwise nobody would bloody use it.
Yeah, Bitcoin has an inflation mechanism that I think I and hopefully many of the people in this room much prefer over the government's and banks' inflation system. Hopefully we're all fans of that, and that's why the block halving.
Hang on, you have to red herring. That's not your argument here.
My argument is it doesn't make any sense to count the cost of a transaction.
I have a service provider, and the service provider is paid.
That's not what's happening.
Cost is eaten by everybody.
That's not what's happening, though.
If demand stays constant, wouldn't the price of Bitcoin go down and everybody's value proportional to the dollar decrease? You're increasing supply, demand is staying constant, doesn't the value go down?
Wait, if you...
Oh, okay, you see.
Of course.
So they're not paying this cost because it's inflation, but they are.
It's not a cost of the payment. It is a cost to the network. It's a cost to the
network doesn't run without the fee. You can't validate transactions without going to the next block.
There's cost of security, so you compare that to national security.
Okay, and then that's a different argument. And that's very legitimate.
There's no. I'm just saying, it's a very simple point. You are saying that some people are paying $3 a transaction.
No, I'm saying everybody's paying $3 a transaction.
Okay, fine. That's not true.
That's what they are paying.
Because I can go outside, send Bitcoin, it's not going to cost me $3. Now, in the time that it takes for my transaction, which I think is the argument you're making, in the time that it takes my transaction, maybe the inflation relative to the amount of Bitcoin that I'm sending might cost me $3 in value, which...
So
maybe
whether
that's-
you
maybe
pay it
that's
or the
case.
recipient pays it by the deterioration of value, by
But
inflation,
no one
it's the same
counts that
argument.
as the cost of the payment. In Visa, you don't count that as the cost of the payment. In SWIFT, in any form of payment, in faster payments, no one counts that as the cost
Visa
of
doesn't
making the
print
payment.
new money to make their system efficient.
The banks that use Visa do.
No, hang on a second
Every
here.
bank,
Hang
every time anyone spends a Visa transaction, they are using a bank that prints money
Well, hang on,
to do
hang
that.
on a second. Hey, let's just follow your argument. Let's follow your argument, son. Let's say that we live in a society where no money is being printed. Okay, it's just fixed monetary policy. Oh, this is great. Come on up for the camera. All right, so let's say we live in a
It'll be
society
more equal this way.
and no money is being printed whatsoever, right?
Okay.
Would there still be a Visa? And how would
Probably
Visa?
not.
Hang on. Probably not. Yes, there would be, because it's a currency, right?
Visa relies on, just to give you a brief sense of
Well, no,
how
we're
Visa was created.
talking about a payment
Visa,
now, son.
hold on. Let's talk about Visa. Visa was created as a decentralized organization, built as a federated system by a number of members, all of which create money. Those members.
You're moving value. We're talking about payment systems right now, not credit
Okay.
systems. We're moving value from Alice to Bob. Okay, we're moving value from Alice to Bob.
Sure.
Over some payment network,
Sure.
and you're trying to equate that this payment network. Okay, so we're moving value over. So in the process of moving value over from Alice to Bob, how does that system stay solvent? You're saying that the only way
Charge
it
a
stays
fee.
so it charges a fee. So what does the fee Alice pay? Some fee. It's a low fee, right?
yeah, sure.
Okay. And it moves it to Bob. Okay. Does the act of moving this money by itself deteriorate the value of the underlying currency? If we're not printing new money, because we don't print money to actually facilitate this.
If she's spending on a good, it does deteriorate the value in a small amount through inflate. That act would be considered potentially.
No, I'm
price
just saying the
inflation.
act of moving.
But monetary inflation, no.
Okay, so it doesn't deteriorate the value, but the act of moving Bitcoin from Alice to Bob to confirm that transaction does deteriorate the value, because you have to print new money to cover that cost.
No, you don't.
You could move gold on the Visa using Visa. You can move gold. What if you could?
Yeah, okay, let's do that. Let's
Wait, hold on.
digitize
I don't see
Visa.
how that's relevant to his question.
Oh, but
and I
it
wanna
is,
ask
because
it-
let's digitize gold.
Okay, but before we go into things that are more theoretical, let's talk about the which is still a theoretical example, but let's talk about the example you just said. So
This is great. I love it.
If you had a system with no inflation, there's just the cost of moving that transaction. That's the only payment cost. And you were saying that because in order to confirm the transaction, there is a cost of inflation that's necessitated by the fact that
You have a Coinbase,
by
and it
the fact-
deteriorates the value. So Bob, if he sends to Alice, Alice loses value, because the currency she's receiving has less value.
That's purely not true. Here's why. So, scenario A: Alice moves value to Bob, 10 Bitcoin, whatever. Scenario B: Alice doesn't move value to Bob. Guess what happens? The monetary inflation of Bitcoin is the same in both scenarios.
Okay,
So
that-
Alice moving value to, so this is
Yeah,
guys,
but what's the
guys,
point of
this is
advancing the
very
network if
simple.
no transactions have occurred?
In both scenarios, the same amount of inflation happened. Did Alice cause any inflation by moving value to Bob?
Oh, no, that's a
I have
false
some
argument. That's a false argument.
I have some Bitcoin on me. I am actively not sending it to all of you guys right now.
Subsidizing miners to secure net.
Yes, that's called inflation. Yes, we do. We do that every day.
It's not inflation. It's you create credit for people.
That's one type of inflation. There's different types of inflation.
The type of inflation.
Well, no, there's many types of inflation. Yeah, let's.
We'll continue this on the bar, okay?
We'll get some drinks
What's your
afterwards.
name, by the way?
Mark.
Nice to meet
I
you,
run
Mark.
the main Bitcoin exchange in the UK.
Okay. Good to know.
Thank you. Any more questions? Good debate, though. Good debate.
Oh, come on, guys.
We
Let's
just,
keep
want to,
going.
we just want to share the love with the room. Anyone else? Any more questions? Oh, you can carry on. Have a fight. Can I just ask? I'll ask. Oh, sorry. Did you?
Oh,
you
go
ask
ahead,
me something?
Gordon.
I want to ask currently is your current venture. Just a few more minutes to talk about that briefly.
Sure, what would you like to know?
I have a question.
Oh, I know. There's like no information there at all, and we have these words cascading disruption. And you can interact with them too, right? Okay, so he's my creative director, and we've been going back and forth about whether that marketing works or not, and I'm very glad that somebody likes it, because I'm in the minority. We're in the business of doing business for the purpose of business. No, okay. So what we actually do is, as I said, we're a service company and a research company, so we build cryptocurrencies on the service side. We're a full stack Haskell shop. We also love Erlang, and so actually we're working on a library called Cloud Haskell, so we can actually do all the Erlang stuff, but in Haskell. And then on the top of the stack, we actually use formal verification for all the code that we write. We also do directed research. So if somebody comes to us and says formalize proof of stake, which we're actually doing at the moment, we'll write a white paper and send it to academia and go through the peer review process and even potentially build a system on that. It just depends on the needs of the client. So we're a service company, but we also do research. Now, as for products we're building, we got something really cool coming out, but we can't talk about it yet. You're gonna love it. He won't, because there's like inflation or something. Sorry, Mark.
Charles, just one question from me about trust and how long it takes to build trust. And I guess it could be argued with Bitcoin, it's gradually getting more trustworthy because it doesn't do very much, and the less it does, the more easier it is for people to trust over time. And 7 years in, it doesn't do very much, hasn't changed very much. So I guess then, on the other side of the coin, you've got Ethereum, and it's probably lost a bit of trust recently because of what's been going on. Are people going to trust Casper now when that comes along? And it takes time, and it constantly takes time. And the more complexity you put in, the more time it's going to take to build trust. So what should developers be doing and learning for the next phases of development to overcome that?
Yeah, trust is a really strange thing in general. It's very hard to build, and it deteriorates naturally. And also that, it's extremely easy to lose. So the question abstractly is, what can developers do to build trust? Well, I guess you can adopt good development practices that are open and transparent, that are modern, so people know that you're doing everything in your power to actually build bug-free code. Second, you have to be very slow and methodical and inclusive in your development cycles. So you cannot just say, I'm just going to release that, everybody deal with it, accept it. Instead, you have to say, I have a proposal, and this is my best idea, and this is the problem I'm trying to solve. Any other proposals? And you aggregate them and have a discussion, and if you include people, they generally tend to trust you more. And finally, you have to be very explicit about your conflicts of interest. One of my big issues with the foundation, the Ethereum Foundation, is that every Ethereum Foundation member seems to have some commercial connection somewhere, or every person involved in the project after I left seems to have some commercial connection. They've gone to Consensus or Slockit or Ethcore or Augur or some other venture, right? And so we're trying to understand, when this person makes a suggestion that we change the protocol or we do X, Y, and Z, are they wearing their I'm an objective foundation member hat and I'm just looking out for all the people who own Ether and I want this protocol to be successful, or am I wearing my VC-funded for-profit corporation hat that not necessarily has that issue? And actually, here's the thing. Blockstream is a great example of where these things can go wrong. So everybody loves Greg and the rest of the guys. They're wonderful people and they're very bright. But the minute that they joined Blockstream and formed this organization, the mere act of doing so started making a certain subset of the population distrust them. So I guess those are the three things. Use good techniques, tools, and methodologies. Be deliberate, slow, and inclusive. And also be very explicit about your conflicts of interest. That's the best kind of abstract answer I can give to an abstracted question. If you're talking about trust in particular, it also depends on your spectrum of decentralization to centralization. You have to make that explicitly clear, because trust is an iceberg. Generally, when I say, here's my service, you see a view of that service, and you don't see the wizard behind the curtain. So it's really important to start draining the swamp a bit and seeing how much you're actually trusting when you use that particular service. And usually failures of trust come from the user not having the right expectations. They thought they signed up for A, but rather they got B. It doesn't usually have to deal with the failure of the protocol or a hack or any of these other things.
Does it, but over time on these large global systems that people kind of do outsource their trust, just in, they once friends start trusting something, they just trust their friends because their friends trust it.
Right.
Rather than actually trusting and understanding what they're trusting.
Yeah, that's exactly right. And think about Web of Trust. So you have two models of trust, PKI and Web of Trust. PKI says, I know these credible organizations exist, and then their job is to tell me who the good and bad people are, or who the legitimate people are. Web of Trust is, it's a decentralized system, and I trust this person based on reference. So if Charles signs your key, maybe I think he does a good job of checking your passport. But if Tom did it, he was probably drunk or something. And just kidding, Tom. So trust is also referential, and it's important to understand it is not an absolute. It's not Boolean. It's not 0 and 1. It's actually referential, and it's contextual. I may trust you to mow my lawn, but not trust you to take care of my baby, right? So trust is domain specific. It's a spectrum instead of a Boolean, and it's always referential to context. And various people have different opinions of people. Some people really like me. Some people really do not like me, and would not trust me to manage a taco stand. And that's referential, right?
Okay, thank you. More questions? Thomas?
What do you think will be the implications of Ethereum hard forking with, say, the Nevada lobby going against Augur, or the banking lobby going against the Maker or MakerDAO? I guess you are part of Beatrice. Do you think this hard fork will have much deeper implications that a 22-year-old can understand?
I don't know in general. I mean, you can always speculate because that's free. So in speculation land, I mean, if you think about the minute that you accept that the miners or the people who secure the network are in some way culpable or have some moral obligation to act in the event that a bad outcome has happened as a result of the use of the system. And that's exactly what's happened at the DAO. Is a bad outcome has occurred, not because of flaw in the protocol, but because somebody screwed up in the design of the smart contract. But the contract was behaving the way it was programmed. So you have a situation where these people said, we have to intervene to save the system. Okay? The minute you accept that, you run into this really slippery slope moral hazard, exactly what you were leading to with things like Augur, where let's say all of a sudden you create like terrorism prediction markets and you create perverse incentives to kill people or perverse incentives to rob or sell classified information, then a government can say, hey guys, you intervened in this case, why don't you intervene in this case? And the problem with mining is it tends to lead to federation because you don't really have a very decentralized set. Usually it becomes a business, and then a group of 10, 15, 20 people end up forming the ownership of the pools, private pools, and it's a business for them. So they can't just grab their miners and go walk away. I mean, it's like giant warehouses with big power lines connected to them, usually in subsidized countries. So the question is, can a government then go in and can coerce them to behave a certain way? But they're not the only stakeholder that has to be coerced. The wallets have to be coerced, the exchanges have to be coerced, in some cases maybe the developers. So it's a more complicated question than that naive notion. But in general, it's a really bad idea, in my view, to start saying that the miner is legally culpable or morally culpable for the outcome of the contracts. This is not the case with Bitcoin. Jerry Brito wrote a wonderful paper called Bitcoin a Primer, and he did discuss this a bit. It was back in, I think it was 2013, from the Mercatus Legal Center. And it was one of those questions of, if I am a miner, at what point does me validating a money laundering transaction or a child pornography purchase transaction legally affect me? And the argument was, it doesn't. Because I don't know, I don't care, I don't have that responsibility. My job is just to facilitate the raw movement of value between Alice and Bob. And similarly, if I'm an Ethereum miner, my job is just to validate the code. I don't care what the code is, the outcomes of the code, any of these things. I've separated myself. What the hard fork has done is established a precedent where that's not the case, in some cases, especially when there's conflict of interest with the foundation.
Just a simple one. Why does marketing in all cryptocurrency, in my opinion, and I don't know in your opinion, why does it sucks? It sucks so much.
Okay. All right, let's say that some mathematician comes up to you and says that, wow, I've discovered this derivative of the Banach-Tarski theorem, and basically it allows you to build a whole new money system. And let me show you how you can like use this. And you're like, wow, okay. and let's build some marketing from it. And the marketing guy looks at it, he's like, I see pretty pictures. What the hell am I looking at, right? And that's kind of the problem with Bitcoin, is that it kind of started from the academic and crypto world and crypto anarchy world, and it was a very different philosophical viewpoint. There was no consumer orientation in the launch of cryptocurrencies. So as a consequence, we have to kind of walk from, let's talk about elliptic curves and whether proof of work is viable or not, and distributed systems and mechanism design, to grandma, and to the guy in Venezuela who's just trying to avoid government inflation and so forth. The second thing is the systems aren't intrinsically usable, because they tend to suffer from a kind of an over-prioritization of privacy and over-prioritization of personal control, whereas most financial systems are the opposite. They are attribution-based, and they are designed in ways to be as usable as possible because they involve custodians. For example, you lose your password, you say, recover my password. You don't have that feature in Bitcoin by design. You don't want feature in most cases. So that's why the marketing tends to be, in my view, pretty bad, because first we're starting with abstract, complex concepts that are born of academia or crypto anarchy or other pools, which are not accessible to everyday people because they presuppose lots of core competencies that are difficult. And then they also, once you've understood them, force you to make compromises in the use of the system, which are difficult to market. So it's one of those problems. I think the marketing has gotten better. I think Ethereum, for its most part, made some innovations in the marketing space, and that's just not me tooting my own horn or anything. I think they really did a good job, and I think some of these ventures, like blockchain.info and others, have certainly done a good job. Shapeshift has done a remarkable job within this community of at least convincing people the service is good. So we're moving in the right direction, but I think it's going to be 5 or 10 years out before we actually have better marketing.
Thank you. And we will finish there. Thank you very much, Charles, as always.
It was a lot of fun,
Excellent
guys.
debate.
Thank you.
Mark and Charles will be in the courtyard afterwards, continuing. Otherwise, carry on, get drinks at the bar. Happy halvening, and we'll see you very soon. Cheers.